Welcome to Insight Hub, the video series dedicated to the world of data and brought to you by Miracle's Data Practice.
My name is Vikas and I'll be speaking about an TensorFlow-powered racing game called FireBalls. This game is a demonstration of how we develop a platform where artificial intelligence, IoT, and mobile are interconnected and how they communicate with each other to output a seamless product. The agenda entails about giving a brief description on the project objective, then we speak about TensorFlow and how we used it to perform image recognition and object detection. Then we move on and explain the technology stack being used and the specification of all the devices used in this project. We then speak about the architectural flow in detail and explain how the events are propagated using the IoT hub among all the connected devices. Finally, we end this presentation by giving a live demo of the AI game in action. We developed an artificial intelligence-based racing experience that seamlessly integrated several cutting-edge technologies to make the users experience the capability of artificial intelligence. We custom designed a miniature racing track on a board and placed checkpoints, power-ups, and power-down sticker on the track. A faster RCNN object detection model was trained using Google's Tensorflow to detect these checkpoints, power-ups, and power-down stickers. We used a Bluetooth-enabled Speedo devices to represent players on the board. These Speedos were controlled by a handheld device, in our scenario, an Android mobile phone. The object detection model tracks the sticker and Speedos on the board. Each sticker represents an event. When a player passes the sticker, these events are triggered and appropriate feedbacks are sent back to the player's device, notifying them of related power-ups, power-downs, and lap changes. Here we discuss a little about TensorFlow. It is an open source library providing strong support for deep learning and machine learning, mainly used for high-performance numerical computation. Originally developed by Google's Brain team to conduct machine learning and neural network researches. TensorFlow provides primitive for defining functions on tensors and automatically compute their derivatives. It also provides an extensive suite of functions and classes that allows users to build various models from scratch. Here we use TensorFlow object detection to perform transfer learning to retrain faster RCNN inception model with a custom dataset to detect these stickers. We selected faster RCNN model after testing several other models as it demonstrated higher accuracies. The technologies that are used to put together this project is as follows. Python is the main programming language used to write the scripts for training and main object detection, and also the event generation. Android was used to develop the game app and the interface. .NET was used to develop Azure functions for developing communication channel for the IoT hub. The entire project was set and run on a Windows 10 machine. Moving on to hardware specification, we made use of Bluetooth-enabled Speedo 2.0 devices to represent players. We used two Android devices running on Oreo or Better OS, a GPU machine with 1080 GTX NVIDIA GPU running on a Windows 10 machine was used. Now moving to event propagation, Azure cloud-based IoT hub is used for all the event propagation from the machine learning model to mobile devices. The object detection model generates the event when the Speedo passes over the sticker. This event is sent back to the mobile device to activate that particular power on the sticker. The mobile controller device sends events to the IoT hub, which is backed by the Azure function which determines the destination of that event or that event's response. Now, moving to the architectural flow. A camera captures the entire game being played on the custom designed racing board. This video is relayed to the GPU machine running a TensorFlow object detection model trained using a custom data to detect the sticker and the Speedos on the board. The model also detects when the Speedos passes over a sticker. Upon this detection, it generates an event and transmits back an appropriate feedback to the mobile device through the IoT hub. We designed a mobile app which is the controller of the Speedos. We connect to the Speedos via Bluetooth and calibrate it using the app. Calibration is basically to sync the Speedo movement with the joystick in the app. Once the Speedos are calibrated, we have a trial run for the participants to ensure they get a hang of controlling the Speedo. At the end of the trial run, the app sends a message to the console or the laptop via the IoT hub and is ready for the race. The console waits for the message from both the players and then sends back a message to start the race. Once the race is started, the Spiro goes over any sticker, the console sends that particular event to that Spiro. For example, when the Spiro passes over a Nitro sticker, the console sends an event or message to the app giving the player the ability to boost speed for 5 seconds. This is the same process for all the other stickers. Whoever finishes their 3 lap first would be declared the winner. In this project, we seamlessly integrated TensorFlow object detection, IoT hub, and Android to deliver an artificial intelligence powered racing experience. Now let's move on to the live demo. The left side of the screen shows object detection where the stickers and the players are being detected. The players are nothing but the two Spiro balls represented by green and the pink ball. The right side of the screen displays two players' mobile devices in which a custom game app is running. Here we can see the object detection model tracks and detects when the player crosses a sticker. So when the player crosses, when the player crosses the red sticker, that player receives a Nitro power-up, and that it is displayed by activating the Nitro icon on the mobile screen. Similarly, players can collect other power-ups that is nothing but the slow opponent power-up. So when the player crosses the blue sticker, the slow opponent power-up is being activated. Players must cross red and black checkpoints to complete a lap. The first player to complete 3 laps wins the race. So here, let's see who wins the race. Player 2 completes 3 laps first and he wins the race. Thank you, and this concludes the presentation.
Thank you for watching a video on Insight Hub. The video series brought to you by Miracles Data Practice. For more videos, please visit miraclesoft.com/insighthub.